Okay, so we're going to take a look at the next chunk here. And let's take a look at parts 4 through 6. I try not to do too much all at once, but these all kind of lay together. So again, going back to our properties that when you have things together, you can pull them apart in a variety of ways or possibly going the other direction. We're going to do a little bit of both. So in this problem, they're asking me to pull it apart because this says I got the log base 4 of t minus the log base 4 of 16. And I can do that because these are being divided, so it can clearly do that. Now I know that 4 to the 2 power is 16, so the log base 4 of 16 is 2. Remember, the definition of a log is, what is that exponent? And up here it says the log base 4 of t is 7. So it looks like my answer is just plain old 5. That was pretty simple. Now over here, the property says I've got the log base of 4 plus the log base 4 of t squared minus the log base 4 of r. But I know up here the log base 4 of k is exactly -3. I know the log base 4 of t is 7, and the log base 4 of r is 1/2. So it looks like I've got 14 here, and I'm going to lose 3.5 or 7/2, depending on how you like to look at that. 28 minus 7 would be 21/2. I like to use that. If you like to use decimals, that works okay too. Now, for part C, we have to be a little bit cautious because I was playing with some of the powers here a little bit. Notice that K and T both have that power of a 1/3, whereas the Y only has a power of 1/2. So what I'm going to do is very specifically be careful to separate them because they have different powers at play. Now we're almost there because now I should be able to substitute. I know that the log base 4 of k is -3, and the log base 4 of t is 7. Over here, the log base 4 of y is -2. So this portion is -1. Over here, I get 4/3 because -3 plus 7 is 4, and a third of 4 is 4/3. 4/3 minus 3/3 is 1/3. Cool. One part down, two to go. Now, this is actually the kind of question I really like to put on tests and quizzes because it just forces you to show that you understand what's going on. When I look at the number 30, my mind immediately goes to, well, 30 is two 15s, and a 15 is a 3 and a 5. So I could say 2 times 3 times 5 would be 30. And that means I've got the natural log of 2 plus 3 plus 5, because remember, you could separate them as individual pieces. And please notice it says, please fully expand first. So that was A plus B plus C. Easy peasy. Okay. Now 54 is a little harder, and because I'm like, well, geez, there's a lot of ways to do that, but I'm just going to go easy on myself. I know that 2 times 27 is 54. But 27 is 3 times 3 times 3. So I'm going to say it's the natural log of 2 plus the natural log of 3 cubed. So remember that you can play that game, that 3 cubed. That 3 that was here can pop in front, right? So this is A plus 3B. Maybe I should show that step. I think I'll do that on this one. This would be the natural log of 3 squared minus the natural log of 5 squared. So that'd be 2 ln's of 3 minus 2 ln's of 5. Yet again, that would be 2b's minus 2c's. See, because once I actually make it look exactly right here, like what it says right here, then and only then am I going to go ahead and substitute that in. Now, moving into here, the natural log of 6 to the 1/3 power minus the natural log of 8. Well, I'm going to bring that 1/3 in, and 6 is really 2 times 3. And 8, of course, is 2 to the 3rd. So again, I'm just doing a couple little things, but I know that the property says when you multiply, you can add, and we can always bring coefficients to the front, right? Those exponents go to the front. So what I've got is a third of an A plus a B, and I lost three A's. Well, that's a little bit of a strange way of doing it because really I've got A's here and I've got A's here. So I've got a third of an A, but I lost three or nine thirds. So I think it would be better to say I had negative eight thirds of an A plus a third of a B. Okay. And last but not least, let's see, I got the natural log of 225 minus the natural log of 16. Now, 16 is pretty easy one because that was 2 to the fourth or 4 ln's of 2. That one feels pretty good to me, but 225. Well, let's see. I don't know. We got to think about that a little bit. I'm going to go because that may not be one that you know off the top of your head, but I think you all probably know that it's got a 5 in it. And that also has a 5 in it. So I took out two fives. So I have a 5 and a 5, and what's less is a 9, but a 9 is two threes. So that would be 2. Let's see, how should I do that? I think I'm going to go two parentheses, ln of 5 plus ln of 3. Since they're both being squared, I could pull out that 2. Or you could distribute and have both of them have the 2. It's the same thing, right? So that would be two C's plus two B's minus four A's. Now, again, lots and lots of ways to do that. Remember, I showed you in class that you can store those values in here. This one already has A, B, and C stored in it. Remember, I could go the natural log of 2, and I could hit the store button down here at the bottom. I could hit that store as alpha A. I could do, see, natural log of 2 stored as A. I could do the natural log of 3. I could hit store as alpha B. Got to be a little bit careful. I should put a parenthesis, store alpha B. And natural log of 5. I'm going to hit the store button again and go to alpha C. Now, again, the beauty of that is that I can check my answers nice and pretty because I could say, well, I have this problem right here that's asking me to take the natural log of 225 sixteenths. Now, that is not an easy number to find. It looks kind of weird. But when I did my math, I got, so 2.64 is my answer, but this is two C's plus two B's. Oops, let me fix that. Two B's, alpha B, minus 4A. Now, again, I'm hoping I got this right because I haven't done this problem on a calculator. Woo, got it. Nice. And easy to check our answer. And then, of course, the last one for my day, and then I'm going to go home, is what if somebody said, hey, let's go back the other way? Well, going back the other way is no big deal because this is two ln's of 2 plus an ln of 3. Well, ln of 2 is ln of 2 squared. That's 4. And again, our properties of logs say that if you have a sum, you can make it a times, or if you have a minus, you can make it a divide. So this would be the 4 times 3, or 12. This would be 3 ln's of 2 minus 2 ln's of 3. I'm literally just turning A and B into the values they were. This would be the natural log of 2 to the third, which is 8, minus the natural log of 3 to the second, which is 9. And of course, when we subtract, that means we were dividing. And we are almost done. Let's see, that would be ln 5 minus 4 ln's of 2. Now, there's not a lot that I can do with these two, so I'm going to leave these alone for a moment. But I can do a little bit with this one and say 2 to the fourth power is 16. So here we go. Our final answer. Oops, I missed my 5 there, didn't I? So I've got the fifth root of, the fourth root of 5 because 5 was to the 1/4 power. So that's the fourth root of 5. This 16 is in the bottom because it's minus. And I chose to write it in front of this one because we usually write nice things before we write ugly things. And this would be the fifth root of 3. It's a fifth root because it's a 1/5 power, and it's in the denominator because it says we're subtracting. And that should finish us up for parts 4, 5, and 6. All right, hopefully that helps. See you later. Bye-bye.